The world's oceans are home to some of mankind's most extraordinary engineering achievements. Out at sea, the megastructure is king. And ships, oil rigs, and floating factories are all growing to an unprecedented scale. But these oversized objects present engineers with a giant challenge. What happens when they need to be moved? Marine engineer Michel Sai is part of the team designing a solution.
The structures for this industry are the biggest in the world that need to be transported. In front of us, you can see an oil rig which is operating around the globe and is difficult to move by itself. The cargoes that we have to transport are in some cases 5 times as heavy as this platform. They need to be transported a distance of over 10,000 miles. That's a trip about half around the world. In order to transport these cargoes, we need to build a unique piece of engineering that's bigger and more capable than anything presently available.
But now, there is an answer. This is the BOKA Vanguard.
This is absolutely a game-changing piece of engineering. She carries some of the largest machinery built on the planet, hundreds of thousands of tons she carries on her back, and she carries it for thousands and thousands of miles.
And the way this vessel pulls it off has to be seen to be believed. The BOKA Vanguard can deliberately sink itself. By submerging below the surface, the Vanguard can load cargo of a truly astonishing size.
She's absolutely amazing. Everything on this ship is different from the standard vessel.
Then, the BOKA Vanguard does something even more extraordinary. It rises from the depths and plucks its mega cargo from the sea.
It's unbelievable if you start thinking about a vessel like this, that you're actually able to lift cargoes out of the water that are weighing over 100,000 tons or even more.
At 902 feet long and 230 feet wide, the BOKA Vanguard is the world's largest heavy-lift ship. On board is a 12-story superstructure that contains the bridge and living quarters. Its 4 90-foot buoyancy towers can be reconfigured for unique loads. And it can sink 66 feet below the waterline before lifting massive cargo weighing up to 120,000 tons. In order for Vanguard to deliver the planet's largest cargo around the globe, engineers have had to solve a series of problems. How can a vessel sink and re-emerge at will while lifting unprecedented weights?
We had to change our traditional designs and come up with something totally new to move cargoes that no other vessel in the world can move.
What does it take to maneuver this monster machine through the world's most dangerous seas?
She has to go around the Horn of Africa, which is some of the most treacherous waters on the planet.
And how does the crew of this prized megastructure protect it from disaster?
So the worst case scenario is damage to the hull of a vessel, flooding of a vessel, and sinking of a vessel.
First mate Rudolf Lamanis and the crew are regularly faced with these seemingly impossible challenges.
We can see actually an oil rig standing there, and you obviously cannot use any kind of crane for lifting this thing out of the water. It's too big, too heavy. There are no cranes in the world that can lift something as big as this. The other option might be towing. So use tugboats and just tow them wherever they need to be. But it means that it takes a lot longer time for us, and it also might be more dangerous. The weather can be perilous outside, and if this structure like this is being towed, it means that she's out there in any kind of weather. There might be storms or high waves, so this is when the submerging of the vessel comes into play.
But is it possible to sink and then raise an enormous vessel and its cargo at the flick of a switch? To find out, the Vanguard's engineers will need to look to the past. On the shores of the Gulf of Mexico.
Are we ready? Okay, we will start.
Marine engineer Krijn Hasnoot is rallying his crew for an offshore adventure.
What we basically do is that we install rocks on the seabed.
Today, the Tideway rolling stone is used in pipe laying operations. But she has a hidden past.
Everything behind me was not there before the conversion in 1994. From here to the casings, it was all just flat deck.
When it was built in 1979, this ship changed the world. This was the Super Servant 1, the first ever large-scale, heavy-lift ship. Capable of sinking at will, she could lift loads heavier than anything that had come before. And the bones of this vessel hold the key to how the BOKA Vanguard works.
The whole deck was empty, so they could take as much cargo as possible. You can see we put a lot of equipment there, but the structure is still the same. If you know where to look, you can see the structure of the old Super Servant all over the boat.
First mate Floris Zeilmacher is on the hunt for the telltale signs of historic engineering innovation.
We have a ballast console over here. It's totally original from 1979. This was the first system of its kind in the world. It's totally unique.
By filling 24 huge tanks in her hull with water, the Super Servant was able to sink its deck 21 feet below the surface. This allowed cargo to float directly above it. Before the tanks were emptied, buoyancy increased and the payload lifted from the water.
This system allows us to raise and lower the ship easily. By doing it this way, we could load floating equipment without using cranes.
The secret behind this game-changing system lies below deck.
We are now in the ballast compressor room. We still have two of the originally 3 ballast compressors. This allows us to raise and lower the ship in a very efficient way.
The Super Servant's compressors were capable of pumping over 88,000 cubic feet of water in and out of the hull every hour, allowing the ship to achieve the seemingly impossible.
This was the first system of its kind in the world. It's truly amazing that even after 40 years, a lot of this technical equipment is still working.
The now converted Super Servant led the way for a new form of heavy lift ship. And few know of its trailblazing past.
We, as a crew, are very proud to work and live on this vessel with such an amazing history. The Super Servant was one of the most innovative ships in the world.
The BOKA Vanguard is almost 7 times the size of the Super Servant and can lift many times the weight. It's the largest semi-submersible lift ship ever built. All thanks to a supersized version of the technology used on the Super Servant, which is hidden in one of BOKA Vanguard's most hard-to-reach locations.
We're at the top of one of the buoyancy casings. There's very few people get to come up here.
When megastructures need to be moved across the world's oceans, It calls for engineering on an epic scale. This is the BOKA Vanguard, the biggest heavy lift ship on the planet. And it's no ordinary vessel. The Vanguard has the astonishing ability to sink itself below the surface of the sea before lifting its giant floating cargoes straight out of the water.
Yes. Okay, copy that. Start the ballast pump. Thank you.
On board, engineers rely on cutting-edge technology to help pull off this complex procedure.
This is the main console. On these monitors here, we can see all our ballast system, the piping, the pumps. These blocks, they represent our ballast tank. Total 96. Each ballast tank is connected with a valve. And on these screens here, we can open and close the valves as needed. When the valves are open, the water is flowing in.
The Vanguard's 96 ballast tanks can take on more than 52 million gallons of water, allowing her to lift weights heavier than any vessel has ever been capable of before.
So in the beginning, when I start my operation, most of the tanks are empty. We start the pumping water from outside of the vessel through the ballast system that goes all around the vessel.
By deliberately flooding the hull, the Vanguard's deck is submerged to as deep as 66 feet below the surface.
As these tanks are being filled one by one, the vessel is going more and more underwater. And then, when we have reached our target draft, we just close the tanks, stop the flow of the water, and then the vessel is in the position.
But the sinking is only the first phase of this incredible exercise. Superintendent Don Kemmler is responsible for maneuvering the massive floating megastructures above the Vanguard's deck.
The seas, they don't care what your cargo weighs, and they will move it around quite easily. The stakes can be quite high because everything that we're moving is in the hundreds of millions of dollars. And the biggest issue that you have with the largest weights when you've got 100,000-ton cargo is momentum. The faster something is moving, the harder it is to stop it. And if you can't stop it in time, then you run the risk of causing damage to either the cargo or the vessel itself.
The solution to keeping these gigantic structures under control.
See, an elevator would have been much easier.
Can be found in a spot that few get to experience on this extraordinary vessel.
We're at the top of one of the buoyancy casings. There's very few people get to come up here.
Not only is the view spectacular, this off-limits location holds the key to helping avert disaster.
This is one of our cargo winches. We have 2 of these on every one of these casings. The winches are specifically to pull in a controlled manner the cargo above the deck. We will have this line down on one of our workboats, which will then run the line out and attach to the cargo. Often we find ourselves, especially with this vessel, working with loads anywhere upwards of 100, 110,000 tons. So these winches are capable of putting a tremendous amount of force on these objects and able to move them quite easily through the water.
It's a technique that allows the crew to precisely maneuver the giant structures into position, reducing the risk of collision.
I'm in communications with all the winch operators, and I will say heave up on line 1, and he will heave up on his, Or I can give them specific directions, heave up 1 meter. And maybe I'm telling the other winch to slack 1 meter. And that's how we can control it and move really slowly. Every time we do one of these projects or one of these operations, it never ceases to amaze me how impressive and how awe-inspiring it is. We could not do our job without these winches.
Thanks to the Vanguard system, 96 ballast tanks, 4 buoyancy casings, and 10 winches, she can achieve the incredible feat of sinking below the surface of the sea and safely moving giant payloads above her deck. But this act of deliberate sinking is just one piece of the puzzle. It will take even more ingenious engineering to pull off this seemingly impossible exercise.
This is a very huge and high-scale operation.
Using 96 ballast tanks, 4 buoyancy casings, and 10 winches, the BOKA Vanguard can sink below the surface of the sea and safely move heavy cargo above her deck. But that's not all this heavy lift ship can do. First Mate Rudolf Lemanis oversees the next step, lifting the massive cargo out of the water.
When we look out of this window during the cargo operations, we only see the casings kind of sticking out from the water, and then we see this huge structure. When somebody asks how big is it, I say, well, imagine a 10, 12-story building. At the final stage of the loading, you just see a wall here of whatever cargo there is.
To finally land the monster payload onto her deck, what goes down must now come up.
So after the cargo is in position, everything is confirmed, my pumps are running. Then I open the valves to the tanks that I need to deballast. The water is being pumped out from the tanks outside of the vessel. This way, the buoyancy is increased and the vessel comes out of the water.
As the vessel rises, it can lift up to 120,000 tons. But as project manager Ronald Gutierrez knows, when you're carrying a massive megastructure, entering the confined space of a port is a tricky proposition.
Not all ports are happy to receive this vessel, especially not with a large cargo, because it scares them off. It's not a usual vessel, it's not a usual site. And because of these challenges, it's important that this vessel can sail halfway around the world without stopping.
Lead engineer Andriy Kurachkin maintains the machinery that makes these voyages possible.
We have 2 6-cylinders engine and 2 12-cylinders engine. This engine has a 6-cylinder, and the output of this one is 4,350 kilowatts. The total power is 26,000 kilowatts.
That's equivalent to the horsepower of 8 freight trains.
All 4 engines at full speed. We sail with 13 or 14 knots. As a normal routine preparation of the engine, we will do the air blow, and after that we will start the engine. That is to verify that there is no any water accumulation in the cylinders. The cylinders are free of water, and there is no any accumulation of oil. So now the engine is ready for starting, and we will start the engine locally.
These powerful engines allow the Vanguard to achieve the unthinkable on each and every voyage.
Sounds good. The engine is ready for operation. These engines are perfectly doing their job. These 4 engines running, we can easily do the voyage from China to Brazil non-stop at full speed, 100,000 tons of cargo on deck.
To complete these global missions, Captain Oleg Maryasov must maneuver the Vanguard and her payload across the world's most dangerous seas.
When the vessel carries big and massive cargoes, the windage area is very high, and the adverse weather conditions with strong winds, the winds can stop the vessel and swing the vessel. It's like a big sail, and if a wind blows to this sail against, it stops the vessel. But we have a time frame to deliver the cargo from one port to another port. And if we lost speed, we lost time and cannot deliver the cargo in time. So during the operation, the captain must keep everything under control.
The answer to keeping the Vanguard moving in all types of weather may lie with the pioneers of the past.
For something 60 years old, this is really, really incredible.
The BOKA Vanguard, the largest heavy-lift ship in the world. This game-changing semi-submersible vessel can deliberately sink itself before rising to lift and transport the largest cargo on the planet. The Vanguard can fill her 52 million-gallon capacity ballast tanks at a rate of over 5 tons per second and submerge 6 stories below the waterline. She's kept afloat by 4 92-foot-tall towers filled partially with air. But out on the open sea, there's an ever-present risk of high winds that could swing and even stop the massive vessel in its tracks. Could the answer to keeping the Vanguard moving, whatever the weather, lie with the pioneers of the past? The River Rhine in Germany. Mechanical engineer Aoife Considine has traveled to this landmark waterway to get her hands on a piece of aquatic engineering history.
Ready for this? This is just incredible! Woo! So you've got 17 tons of vessel here and at 15 meters. I mean, you can just see the weight going out the back. For something 60 years old, this is really, really incredible.
In 1963, engineer Josef Becker launched the Forelle, a pioneering boat designed to solve a problem.
Now, in a conventional boat system, when you have a separate propeller and rudder, you have to have forward movement and momentum before the boat can actually even start to turn. For a boat such as this, that is 15 meters long and it weighs about 17 tons, you are going to have a tough time navigating around tight inlets. It's actually quite difficult to maneuver.
What Becker came up with allowed the Forelle to move on the water in a way that had previously been impossible.
He managed to combine both the propulsion of the boat with the maneuverability in a 360-degree rudder propeller.
On conventional vessels, thrust and steering are separated, meaning changes in direction are delayed. By integrating rudder and propeller into a single unit, reactions are instantaneous.
The way it works is the engine, which is the main powerhouse, that provides the energy down a drive shaft towards the back of the boat, which then does a 90-degree turn going downwards, a second 90-degree turn, and then that actually leads straight onto the rudder propeller, which provides both your horizontal degree of axis turning for your maneuverability, and also has a propeller turning at the same time.
Becker's innovative system was the perfect solution for improving the agility of boats.
Now, to try and do this kind of maneuver in a conventional boat, you have the propeller and the rudder both separate, so it isn't that instantaneous movement that we're having right now. So how it actually works, if you look at these gauges here, your arrow's pointing your direction of travel. So, say for instance, we wanted to turn right quite quickly. All we do is turn the wheel twice for 45 degrees, and already you can see the boat is moving. And actually what's happening is as I turn this wheel, the propeller underneath the boat is mimicking that movement and allowing for that instantaneous change of direction. Turn it 2 more times again. And as you can see, the dial is moving with me, which is exactly what's happening with that propeller to be able to push us in this clockwise direction. And it really is just that simple.
The rudder propeller allowed for control and maneuverability previously thought impossible.
So let's spin this girl around and see what she's got. It really does just react immediately to what you're doing. The boat is literally spinning on its own axis.
Becker's invention is now the standard on ships around the globe. On the Vanguard, Chief Engineer Andriy Kurachkin has access to a supersized version of Becker's innovative technology.
We are now in one of the unique compartment of the BOKA Vanguard. We have on board 2 thrusters, 3,000 kilowatt each.
Manufactured in China, each propeller measures just over 9 feet across and is precisely engineered from copper alloy. The massive props are housed inside a cast steel pod, allowing them to rotate 360 degrees, just like on Josef Becker's Forelle. But the versions found on the Vanguard have an extra trick up their sleeve.
Once you want to run this thruster, hydraulic power is used to deploy the thrusters from the hull. The gearbox will move down. This will push the propeller and pod out of hull.
Normally stored inside the hull to reduce drag, the Vanguard's rudder propellers are deployed using giant hydraulic rams, capable of turning through a full 360-degree range of motion. They provide the thrust required to counteract wind and waves that could push the ship off course. For Captain Oleg, the rudder propellers are key for maneuvering the Vanguard.
So let's say if wind blows from the starboard sides, the vessel has tendency to go to the port side. To prevent that, we use the thrusters. We turn it to the starboard side and increase the pitch on the propellers. The vessel will go to the starboard side against the wind. They give us additional power and help keep the heading against the winds and waves.
But in order to safely deliver these supersized structures, the Vanguard must be protected from the risk of a collision at sea.
So the worst case scenario is damage to the hull of a vessel, flooding of a vessel, sinking of a vessel.
The key to avoiding catastrophe lies in one ancient shipbuilding method that played a revolutionary role in improving safety at sea.
When they built the ship, the most clever part came later.
This is the BOKA Vanguard, a one-of-a-kind ship of record-breaking proportions. she's capable of feats that no other vessel can achieve, transporting impossibly massive payloads over tens of thousands of miles. Measuring in at 902 feet long and 230 feet wide, the Vanguard has enough deck space to carry the Eiffel Tower and enough lifting capacity to carry the weight of 10 of the iconic French landmark. But as Captain Oleg knows, when you're transporting the planet's largest cargo, sustaining a collision on the journey could be catastrophic.
Any case of collision is very serious. The worst case scenario is damage to the hull of a vessel, flooding of a vessel, and sinking of a vessel.
To prevent disaster, the Vanguard's designers must look to the maritime pioneers of the past. In Shanghai, China, Professor Xiaoying Jia is on his way to uncover the secret behind one of the most iconic and influential vessels in maritime history, the Chinese junk.
This is an amazing Chinese boat built for exporting and trading since Tang Dynasty. Very beautiful.
First appearing on the water more than 2,000 years ago, the junk's immediately recognizable spined sails and sleek shape marked a huge step forward in shipbuilding technology. But arguably, its most important design feature helped solve a problem that had been plaguing Chinese sailors.
The ships would be offshore for a long period of time. If they are damaged in the storm, the crew will be lost or cargo will be damaged. The ship needs a solution for the safety of crew and the cargo.
Early vessels had one large compartment below deck, so any water that entered would fill the hull and sink the ship. In order to avoid this fate, engineers went back to the drawing board.
When they built the ship, the whole part came first. The most clever part came later.
It's a solution that helped redefine maritime engineering for generations and will prove critical to keeping the BOKA Vanguard afloat. The only way to see this hidden innovation is to head below deck.
This is it. Watertight backhand. The idea is to divide the hull into separate parts. The backhand strengthens the ship, reducing the flooding water in emergency.
Dividing the junk into multiple watertight segments offers two crucial benefits. The lateral divides make the hull more rigid, giving greater structural strength. And in the event of a collision, water can only fill one compartment, preventing the ship from sinking. Introduced on the Chinese junk hundreds of years before it caught on in the West, the bulkhead revolutionized shipbuilding.
This is a boat without bulkhead. The problem is when it has emergency. The ship is sink because the whole boat is full of water. And this time, it is a ship with bulkhead. When in the emergency, only one compartment is full of water. But it is safety. This is a very clever design. It is repeated in the history.
The introduction of bulkheads allowed junks to sail the oceans in safety for thousands of years, influencing ships of all shapes and sizes along the way. And today, the Vanguard's engineers have taken this Chinese concept and implemented it on an enormous scale. For thousands of years, the watertight bulkhead technology of Chinese junks has kept countless ships around the globe safe at sea. This ancient technique is considered a great invention in the history of shipmaking, and it's been incorporated into the BOKA Vanguard's design.
There's a lot of awkward spaces down there. It's really tight. So when we climb down, take care not to injure yourself.
Chief Officer Rudolf Lamanis is leading engineer Michel Sai deep below deck to examine the Vanguard's enormous bulkheads.
Watch your step. It's really slippery and lots of tripping hazards.
It's a location that's hard to reach and few ever get to see.
So you were working on the design, yes?
Yeah.
It's quite high.
Yeah, 10.3.
10.3 meters high.
I still remember the dimensions.
Although this cavernous space is rarely accessed, it's essential to guarantee the safety of the Vanguard in case of a collision.
On the other side of this skin, we have the ocean. One of the risks during a transport is a collision with another vessel. If the skin would be damaged, this whole tank could be filled with water.
But just like on the Chinese junk, bulkheads help the Vanguard stay safe at sea.
In this vessel, we have 96 ballast tanks, each of them surrounded by these bulkheads, running from starboard to port side and from fore to aft. Here you can see one of the bulkheads. These will prevent the water from flooding in the rest of the vessel once a tank would be damaged. This single tank could hold about 6,000 tons of water in itself. These steel plates and the enormous brackets will hold the pressure acting on the other side of this plate. Knowing that this tank is only one of the 96 ballast tanks, it shows the sheer size of this vessel.
The Vanguard is equipped with 10 bulkheads, 3 that run the length of the ship, and 7 across the width. If a collision were to occur, these 20-millimeter thick steel walls are capable of withstanding over 5 tons of water per square foot. They also provide structural support, helping the Vanguard bear the immense weights loaded on her deck.
These bulkheads are the backbone of this vessel. These are essential for the structural integrity of the vessel and the safety of the vessel in case of a collision. Without these, the vessel couldn't carry these huge cargoes.
At 902 feet long and 230 feet wide, the Vanguard is truly a vessel of epic proportions. Thanks to her immense ballasting system, arrangement of enormous bulkheads, innovative buoyancy casings, and pair of retractable rudder propellers. She's able to lift and transport loads that would otherwise be impossible. For all those involved with the Vanguard, being part of this record-breaking project is a great source of pride.
In my opinion, this is a really incredible vessel, and there's no other vessel like this in the world. And for me, I'm very happy to be here and to be part of this